So I've got a brief video here that's actually recording another older video that I've done on a historical 326 homework assignment. But this goes into using the solver to analyze data on Excel. And so I'm just going to highlight how the Excel file was built, and I'll play that. And so this is about 6 minutes or so, and I'll go through some of the examples. So this was recorded on a different medium, so I'm going to go ahead and play now, and I'll be quiet.
So we go back to our solution, all right? And so that's what I've calculated on here, sum of squares total. So let's just go back and review data, formulas, trace dependence. And again, we're using this average well-color development. There's the average that goes into it. So again, that is the data point minus the average, and it should be squared. Yep, indeed it is. And we just do that for each one of these steps that's on here. And so we can look back here and we can see each one of those is through. So let's remove these. And so we have our sum that's here at the bottom. Now let's go to sum of squares error. And so this formula is using the value minus, or data minus the model, and it should be squared. And indeed that is correct. And we have our sum.
Now I'm just doing some stats on here. I'm over talking some historical voices or historical work that I've done. And we're just kind of going through some statistics and looking at essentially average well-colored development as a function of time for some microbial system. But the key is what's going to come up here in a little bit.
R-squared, let's just look at what this is.
There's two of me here.
So this is the, okay, so we have 1 minus, oh, I forgot, let's go back here. So this would be sum, and this would be sum. Is that correct? This would be, yep, so that's the total of the sum of squares total divided by sum of the squares. This could be error divided by total minus 1, and so we're trying to keep that, and obviously this one's been calculated at 0.8. And so we again have the sum that's on there, and we can look at, review what's, oops, let's get out of that, click here, data, formulas, and trace dependence, and so we got this whole box here, and let's remove these arrows and trace, and so again we're using these values that are here. And so the next step is, how do we solve for this? I mean, we've got a pretty complicated equation where these calculations here are highly dependent upon these values, and we're trying to optimize this this value here to get that r-squared equal to 0. And so how would we do that? Well, we would first need to get the solver. And so this is a new computer. My other one was wiped out recently. And so I don't think I've loaded the solver onto Excel. So let me show you how to do that. So let's go to Options, Add-ins, and we typically, I'd always say add the Analysis Tool Pack, and let's add the solver. It looks like we can only do one at a time. Well, let's hit Go. Maybe it's there. Let's hope it is. File, Options, Add-ins, and Solver Add-in, Inactive Add-in. So we need to make this, okay, so we have to go to Manage Excel Add-ins, and maybe we double click on this one. So hit Solver, Excel Add-ins, so Solver Add-in, hit OK.
I'm still having trouble.
And let's see if it's added it in there. So let's go to Data. Looks like we might have to add the, let's try this again. So add-ins, add-ins, add-ins. So let's go to the Analysis Tool Pack. Okay, location, Microsoft, so provides, and so manage add-ins, disable items, actions, and hit go. Okay, no. Maybe it's here. Let me check and see. Okay, I think I got it now. So if we go to Options, Add-ins, Solver Add-in, let's go to Excel Add-ins, hit Go. And so now we want to add the Analysis Tool Pack.
Ah, there it is.
And the Solver. And let's hit OK. And it should add those. And so notice now we have some data, and we also have the data analysis and the solver now. So that's great. So now let's go and actually run the solver, and this will be a big trial run here. So we want to set the objective. So we want to, looks like this cell here is referenced to this cell, and we want to get a maximum value of 1. So our ideally 1.0 would be our goal. You know, we're essentially doing a goal seek with this. And we're going to change these variables. So we've got this one, and this. So it's going to do guesses for these variables. And we can just highlight those cells. And by changing those variables, you can click here to select the proper cells when you design this one. Okay, and we want to make sure that those are non-negative. Those shouldn't be negative values. And there's a bunch of different solver methods. Let's just leave that as the default. And let's hit solve, and kapow, let's see what happens. So solver cannot find a feasible solution, but I bet it's pretty darn close. So let's keep the solver solution. Good if we wanted to restore it. And let's hit OK. And wow, all right, it did work. It didn't get it to 1, but boy, it sure got it close, 0.09 or 0.999. And wow, look at this this data set here. The model is right on top of the data set at this point, and so that's really good. And so, and these are the K values and the P value and the S value that did that go round and made that data exactly correct. And
so that was how you use the solver. And so essentially you can highlight the cells that you wanted to guess for or solve for and optimize for certain values. And so it's quite powerful. So hopefully this helps. Sorry about the audio quality, and we'll stop here.